All right, so prove that the fact that n's not prime implies that 2 to the power of n minus 1 is not prime for integral n bigger than 1. All right, in order to do this, I'm going to first remind you of an identity that you should know. Now, if you have something like x squared minus 1, that's equal to x minus 1, x plus 1. We're aware of that one. What if it was x cubed minus 1? Right? Well, there's an identity that says that will be x minus 1, and then it'll be x squared plus x and plus 1. So if you were to expand that, you would see that that would give you x cubed plus x squared plus x minus x squared minus x plus 1. So, minus 1. So you would end up with x cubed minus 1. All right. And I'm going to allege for you here that x to the 4 minus 1 is x minus 1 x cubed plus x squared plus x plus 1. Now, where is this coming from? Well, here's one place that you can get this from series. If you were to add up the series 1 plus x squared plus x cubed, if you were to add up that series, you would be using that formula that the geometric series sum is a times r to the n minus 1 over r minus 1. You'd be using that formula, and when you plug the numbers in, you'd get 1 times x, because your common ratio is x here. You times in by x to get from the first term to the second, and the second to the third, and so on. And so you get x to the, there's 4 of terms, 4, minus 1 on r minus 1. Now, you can see that if you just grab this and multiply both sides by it, you'll get x minus 1 times 1 plus x squared plus x cubed equaling x to the 4 minus 1. All right, so that's a pattern. All right, if I had x to the 7 minus 1, then I could say that x minus 1, and then it's going to be x to the 6 plus x to the 5 plus x to the 4 plus x to the 3 plus x to the 2 plus x plus 1. And that's because of summing up the series that would be given by this. So if I was to sum up that series there using this formula up here, well, then all I would do is say 1 into x to the 7 minus 1 over x minus 1 is equal to that series there, and then rearranging it, and I'd get that identity. So that's going to be very important. I'll write down the identity that I'm wanting to use. X to the n minus 1 is equal to x minus 1, x to the n minus 1, plus x to the n minus 2, plus all the way down to plus x plus 1. That's pretty important stuff that, well, you can look at it from that point of view, that it comes from our work on geometric series. All right, so back to our original question. Prove that if n is not prime, then 2 to the n minus 1 is not prime. Okay. Also, a prime number, one way to look at it, it has exactly 2 positive factors. A lot of people say the only factors are 1 and itself. Exactly 2. So it can't have just 1, like the number 1 is 1 lot of 1. It's only got 1 positive factor. That's no good. The number 4 has got, like you can go 1 times 4, but you can also go 2 times 2. So there's 3 positive factors. It's not prime. A prime number has exactly two positive factors. So that's an important thing to know as well. All right, so we're given that n is not prime, right? We're given that. So I need to get another page here, and I'm going to work out how I'm going to get down there. Well, it's not going to be via that method. Let's just try to get down and get another page and put another page break in so that we can keep going. So we're given that n is not prime. So therefore n is equal to x times y, where x and y are integers, and x is bigger than 1 and y is bigger than 1. In other words, we're saying that x and y aren't just the number n and the number 1. Right? There's something else. They're two numbers that times together to equal n, because it's not prime, so therefore it has a couple of factors that aren't 1 and itself that times to be it. That's what we're saying there. All right, so 2 to the n minus 1 is the same as 2 to the xy minus 1. All right, so that's 2 to the x to y minus 1. Now we can use our identity. That's the same as 2 to the x minus 1 times, and then we've got 2 to the x. Now that's powered up to y minus 1 plus 2 to the x, and that's powered up to y minus 2, and all the way down to the last thing, 1, using that identity up here, where the number that's the base, in this case x, is powered up to 1 less in the second set of brackets. It's powered up to 1 less than the power n there, and it goes all the way down to 1. So, oh, come on, the birds are fighting outside. All right, so that's what we've got there. Now, what's going to happen here is this here is an integer, and this here is an integer. So we've got an integer multiplied by an integer, because x and y, and the reason they're both integers, so like 2x minus 1 is an integer, and 2 to the x y minus 1 plus 2 to the x y minus 2 plus 1 is an integer, because x is bigger than 1, y is bigger than 1, and x and y are integers. So it makes those be integers. But therefore 2 to the xy minus 1 equals an integer not equal to 1, like a positive integer not equal to 1, multiplied by another positive, and it could be the same one, but a positive integer not equal to 1. So therefore 2 to the xy minus 1 is prime, and therefore 2 to the n minus 1 is, sorry, not prime. Oh, the opposite, it's not prime, is not prime. Therefore, if n is not prime, then 2 to the n minus let's just slow down, we'll write this carefully, then 2 to the n minus 1 is also not prime. Yay!